Okay, so some of the vocabulary you're going to recognize pretty quickly. There is a definition and then a picture. Sometimes the picture will be really helpful. The first one says a segment from the point on the circle to the center. Alright, so it's talking about here's the center, any point on the circle we can draw it. This is called the radius. Because it goes from the center to any point on the circle. Alright, the next one, it says a segment that contains the center of the circle. So I go through 2 points on the end point of the circle, but I also go through the center. The fact that it goes through the center is really, really important. It is the diameter. And I think you know that if you know the radius, you can get the diameter, the length of it, by multiplying by 2. Okay, the next one, it says a segment whose endpoints lie on a circle. That is called a chord. So chords just connect. It just goes from one endpoint to another endpoint. If it goes through the circle, that's a diameter, which is also a chord. But if it doesn't go through the center, that's okay. It's just as long as it connects any 2 points on the circle. And that's an example of it. Alright, the next one, instead of a segment, the next one is a line. Notice how it extends past the circle. That's the only difference between these two. These two stop, and this one keeps going. It is a line. This is called a secant. The secant is a line that goes through 2 points on the circle. Okay, the next one is a line that touches the circle. It only touches the circle at 1 point. This line is called the tangent. It also tells you that it is perpendicular to the radius at the circle at its endpoint. That means that if I connected the radius to the place that it's tangent, that it would be perpendicular right there. Okay? That the angle is 90 degrees. And that'll be important later. Okay, the next one says a point where the tangent line and the circle intersect. So they intersect right here because that's the point on the circle where it's on the line and on the circle. This is called the point of tangency. Because it's the point where the two things meet. Okay, next it says angle whose vertex is the center of the circle and whose sides are the radii of the circle. So the vertex is at the center. That means that the pointy part, the part where the angle is, that's at the center. And we connect 2 radii. So it has to be radiuses that connect it. This is called the central angle. You're going to be looking a lot at angles, especially tomorrow. And the fact that it's coming from the center is important. So coming from the center, that's the central angle. This is like the notation. If you wanted to talk about this angle right here, it would be angle APC. The vertex is in the middle. And so you just start, and it could be CPA. It doesn't matter as long as P is in the middle. Okay. Alright, the next one, it says the angle that an arc makes at the center of the circle of which it is a part. Okay, this right here, it's a little curvy thing. It's hard to tell that, but that's a little curve. It's not a line. Okay, and this is saying the measure of the arc of AB. This right here is talking about the measure of this right here. Not necessarily how long it is, but how much it turns. So it's still an angle, but it's how much it turns. And that is called the measure of an arc. Because this thing right here is called an arc. An arc is just that curvy part of the circle. And if we want the measure of an arc, we're wanting to know how much it turns, kind of like an angle. Okay? Alright, there's 3 arcs that are important to us. The first one is the arc of a circle whose endpoints are the endpoints of the diameter. Again, this is kind of curvy right here. And this is saying start at A, go to C, then to B. So, and I'm going to highlight that. So, start at A, go to C, go to B. That's the arc it's talking about. That's half of a circle. And so that arc is called a semicircle. Which makes sense because that's only part of the arc and it's half of the circle. Okay, the next one says an arc whose length is less than 180 degrees. And the example was arc AC. So start at A, go to C. That is called a minor arc. Whenever you're given an arc, if you're only given 2 letters, you have to go the shortest way. Okay? On this problem right here, I could not go from here all the way around to C because that's the longest way. If there's only 2 letters given to you, it's a minor arc. And it has to be the shortest way to get from A to C, okay? If they give you 3 letters, you start at the first one, go to the second one, go to the third one. That's the order that you go in. And so this ends up being an angle or an arc whose measure is greater than 180 degrees. For example, it says, start at B, go to A, go to C. I see how that's more than 180 degrees because that's going around more than a semicircle, more than 180. So this is called a major arc. Now, that's your vocabulary lesson for today. So now we just need to talk about how we use all of that vocabulary to answer some questions. Okay, so you still need your sheet out so you can look at some of what the words are talking about, and we're going to talk about how that relates to some problems. So the first problem here, it says identify segments or lines that are a radius, a chord, a diameter, a secant, a tangent, and a point of tangency. So looking at the picture, we're going to identify all of these things. Okay, so we need to find a radius, we need to find a chord, we need to find a diameter, a secant, tangent, and point of tangency. So we're looking for all of these things in this picture above. Okay? What you need to keep in mind is that 2 of these are lines, the rest of them are segments. If they are a line, when you write them, you write the 2 letters, but then you write a line above it. So these 2 are the lines. Okay? Tangent is the one that like sits right beside the circle and like connects only at one point. Okay? Tangent would be this line right here because this is the only one that sits like beside the circle and connects at the point. And what we do here is we say, and I'm not sure why, but there should be another letter here. Let's put a G on the end of this. Okay? The tangent would be BG. You always say 2 letters when you say the line or the segment. And because tangent is a line, we put a little line above it. Alright, a secant line is another line in the picture. It's just connecting 2 points on the picture. Okay? 2 points on the circle. So the only other line I see is this one right here, and that would work because it's connecting those 2 points right there. So again, you write 2 letters, and then you write the line above it. Alright, the other 3, radius, chord, and diameter, they are segments. Okay? When you write a segment, you still write 2 letters, but you just write a segment above it instead of the arrows. Okay, radius goes from the center to a point on the circle. And there's only one I see in the picture. So the radius is going to be right here, because it's going from the center to some point. That's AB. And then you put a little line above it, but without the arrows, so because that means segment. Okay, a chord would be connecting 2 points on the circle, but it doesn't keep going like these right here. It just kind of stops. So this right here would be a chord, EC. A diameter goes from one point on the end of the circle to another point, but it also goes through the center. So that would be DF. Last thing it asked me to find was the point of tangency, and the point of tangency was the point where the tangent line and the circle met. And that was this point right here, because that's the tangent line, that's the circle, they meet right there, so B is the point of tangency. Alright, the first one says AC. So we're coming from A to C. That's the center to like the outside of the circle. That's called the radius. Okay, the next one says DE. DE, so it's this line right here. Notice that this line only intersects the circle at one point. The line that does that is called a tangent. So this one is called a tangent. If it intersects the circle only at one point, that is a tangent. Okay, next it says AB. Notice AB goes from the end point to the end point and also through the center. That's the diameter. As long as it goes through the center and the end points of the circle, that's correct. Okay, the last one says, and it's kind of tricky the way they wrote it, but it says AE. And AE is pretty much the same as AG. They just wrote it really weird. Okay? And AG, and also AE, that goes through 2 points on the circle. Notice they have little lines on the end. Might be hard to see, but there's lines there. Because that's a line, that is a secant. If they would have written it this way, AE with the little segment above it, that would have been a chord. That's the only difference between secant and chord, is the fact that secant is a line, but chord is a segment. And really it would be AG instead of AE, but anyway. Alright, so one of the rules in the definitions over here, it said that for a tangent, it must be perpendicular to the radius at the circle at its end point. Okay? That means that this right here has to be a 90-degree angle. The question here on 3 through 7 is talking about, is the line that they give you a tangent or not? And the way to prove it is to use the Pythagorean theorem to see if it's a 90-degree angle or not. Okay? So if AB is tangent, that means that there should be a 90-degree angle right here. If there's a 90-degree angle right there, then that means Pythagorean theorem has to work. So what you do is you just check to see if Pythagorean theorem works or not. Okay? Across from the 90 is the 34, so that's the hypotenuse. So you take 16 squared plus 30 squared, and you try to see if that's equal to 34 squared. Okay? You just put it in. 16 squared plus 30 squared. That's 1156. 34 squared is also 1156. So the side squared equals the hypotenuse squared, and because that is true, then the answer is yes. It is a tangent to the circle because Pythagorean theorem works, which means it is a 90-degree angle. Okay? So next one, if I'm going to do that one, I'm going to check and see 20 squared plus 21 squared. I'm going to see if that's equal to 28 squared or not. Okay? So 20 squared plus 21 squared is 841. 28 squared is 784. The answer is no, because those two things are not equal. Okay? Alright, so that's how you tell if it is tangent. But sometimes they say, well, let's figure out the length of one of the sides. Right here, it tells you it's all tangent. But what we want to do is we want to find something. We're still going to use Pythagorean theorem to find it. Okay? So it's asking me to find the length of BD. So it wants me to find this side right here. So I'm going to use Pythagorean theorem to find it. Okay? So I'm going to do x squared plus 5.5 squared equals 10 squared. Remember that the one that's squared over here is always the one across from the 90. Okay? So at that point I'm going to subtract. I'm going to do 10 squared minus 5.5 squared. I get 69.75. And then I'm going to take the square root of that. And I get 8.35. Alright, number 6 and number 7 are a similar question, but the difference on these two is that the radius is part of both sides. Okay? It's kind of weird because we've got a radius here and a radius here, and we're trying to look for the radius. The hypotenuse is actually 3.6 plus r. And I know that's kind of weird, but that's what's going on there. So when I'm trying to find r, what I'm going to do is start with the sides, r squared plus 4.8 squared. And I'm going to equal it to 3.6 plus r squared. Again, I know that's really weird. What you're going to have to do here is FOIL. Okay? I'm going to leave this as r squared plus 4.8 squared. You've got to multiply this out, so it's like 3.6 plus r times 3.6 plus r. And that's really strange, but that's what we have to do here. So 3.6 times 3.6 is 3.6 squared. 3.6r and another 3.6r. You can just go ahead and add those 3.6's together, and you get 7.2r. And then r times r is r squared. The good thing on this particular problem is that the r squareds, when you subtract them on both sides, they go away. So we get something fairly nice that we can solve. What we do is we subtract 3.6 squared. So 4.8 squared minus 3.6 squared. You get 10.08. That equals 7.2r. And then what we do is we divide that by 7.2. And so we get r is 1.4. This problem right here is probably the hardest one that you'll see today. The others are, I think, more straightforward. This is probably the hardest one that you'll be looking at. Okay? We're going to skip 7 right now and go on to some of these other problems. Some people call this the party hat theorem because that looks like a party hat if you put it up to the side. Basically what it tells you is that if you have two segments that are joined together at the end, that these two segments are equal to each other. So you just take 3x plus 4 equals 28. Subtract 4 on both sides.